All right, good morning, boys and girls, or afternoon, depending when you're watching this. So this is your warm-up. You have these two questions. The first one says, what is the constant of proportionality? So you have to find the constant of proportionality from the table. Remember, your formula for constant of proportionality is K equals Y over X. All right, so you're going to use that to find your constant of proportionality. This says Mrs. Vu transferred 1,020 photos from her phone to her tablet in 17 minutes. At what rate does her phone transfer photos? At what rate does her phone transfer photos? Rate is your keyword. Okay, it's telling you what you're doing. So rate, you're finding unit rate. Okay. All right, so go ahead and pause your video, work out the warm-up problems, then come back and finish and get started on your notes. Okay. So we're going to move on to the next slide. So today we're working with similar figure properties, and so you'll get a little bit of information on that. So today we're talking about similar figures and just the properties. What makes a figure similar? Okay, what are the characteristics? How can we identify if they're similar figures? Okay. So our objective for today says I can generalize the critical attributes of similarity, including ratios within and between similar shapes. So similar figure properties. Similar figures have the same shape and may be different sizes. Okay, so these are your blanks for your notes. Same shape, different size. Okay. So this is what these are your blanks. Same shape, different size. All right, moving on to our next slide. Okay. This here's how many degrees are in a triangle. So this is just a refresher from previous years. You should know how many degrees are in a triangle. I'm gonna give you a little bit of time to think about that. Okay. So how many degrees are there in a triangle? Correct. If you said 180 degrees, you are absolutely correct. So how many degrees are in a square? So take time to think about that. Sorry. Right. All right. So if you said there's 360 degrees in a square, you are correct. For a square, think about it. A square is just like having two triangles. If you cut that square in half diagonally, you're going to have two triangles. So it is 360 degrees. All right. So now it says, what do the hash marks mean? So these are the little hash marks. Does anybody know what they mean? Okay. All right. So if you said that those mean that those lines are equivalent, you are correct. So it means that those are the corresponding sides, and those sides are equivalent. Okay, so those lines that they are equivalent, they are the same. Okay, so this line with one hash is the same as this line, whereas the line with two hashes is the same as the line with the two hashes, and the one with three is the same as the one with three. Had to go up a little bit. Okay, equivalent or corresponding sides. What do the half circle marks mean? So these little circle is more of a quarter of a circle. Sorry, guys. But what do those mean? Does anybody know what those mean? So it means the same thing as the hash marks, except that those are for the hash marks are for sides. Those are for angles. So equivalent or corresponding angles. Okay. So this angle is equal to this angle with 3 is equal to that angle is equal to that angle. So it means they're equal, they're the same. All right, moving on to our next one. On your note, so it says parallelogram ABCD is similar to parallelogram WXYZ. So these are similar. So it says corresponding angles in similar figures are congruent. Okay, so yes, angles that are corresponding are congruent. If you took this shape and slid it over here, these lines would line up. And that's why on the previous one on the previous slide where I showed you that told you that these are equal or congruent, that's why I said that. Okay. Corresponding angles are angles that are in the same position in similar figures and they measure exactly the same. Okay. So in similar figures, your angles are congruent. They're in this and they're in the same position. So they measure exactly the same. So if this is not a 90-degree angle, this is less than 90 degrees, but so let's say it's like an 80-degree angle, then this here would also be an 80-degree angle. I'm just putting a number out there. I'm not saying that that's a 90-degree angle. Okay. All right, moving on to our next slide. So looking at these two, says which angle corresponds to angle A. So I'm going to use my different colors to identify my corresponding angles. Start here. Angle D is going to correspond with angle C. Angle C is going to correspond with angle Y. So this should be 2 hash marks or 2 round little circle thing. Angle B would correspond with angle W. Okay. So then that just leaves us with A. So angle A, and that one's going to have 4, is going to correspond with angle W. Okay. So now we can fill in our table. So which angle corresponds with angle A? Well, angle A we said corresponds with angle W. Okay. Then which angle corresponds to angle D? Okay, well we have D. Angle D corresponds to angle Z. So if you look here, this little mark here, I'm drawing it again. That means angle. Okay, that's oh, I didn't mean to clear all that. That means that was angle. I'm so mad. Now I have to go back and redo this so we can have it. Let me do it real quick. I may not remember the colors exactly, guys, because we had them. I'm trying to. I think this was blue here. Since I accidentally hit clear all annotations or clear annotations. Okay. So we said angle A corresponds to angle W. Then we have angle D, and we said angle D corresponds to angle Z. Then we have which angle corresponds to angle B. So angle B is here. So angle B corresponds to angle X. Remember we labeled it with our little quarter circles. And then which angle corresponds to angle C? Which corresponds to angle C? Angle Y. Okay. So yes, and so like I was telling you before I accidentally cleared off all my annotations, this means angle. Okay, so when you see that sign, it's asking you for angle A, angle D. Okay. All right, going on to our next slide. Let me scroll up on here because we're going already towards the bottom. All right. So it says corresponding sides. Corresponding sides are of similar figures are proportional. Corresponding sides are matching sides of two or more polygons. So corresponding sides are not congruent like angles. They are proportional. So whereas our angles were congruent, our sides are only proportional. So let's go. Okay. Um, so for here, where we said when we're talking about similar figures, they're only going to mean that they're corresponding sides. But if you see it for other, like on other things, it means that they're congruent. Okay. So like if you have, if it's asking you for perimeter and you had the measurement on one side and then it had the line on both sides, then that means that they're congruent. Okay. So for similar figures, it's just going to mean that they're corresponding sides. Just want to clear that up before we get too far in and you get confused. Okay, so going back to this part, corresponding sides of similar figures are proportional. Corresponding sides are matching sides of two or more polygons. So we're going to look at corresponding sides now. So we looked at corresponding angles. Now we're going to look at corresponding sides. So for corresponding sides, we have the same rectangles, or same parallelograms. Now we're going to look at our corresponding sides. So I'm going to color code my my sides so I know which goes with which. So here, and these parallelograms are facing the same direction, so it makes it easy. Sometimes they are going to be facing different directions, so it might make it a little bit challenging. So I'm going to start with AB. Line AB is up top, right? And that is going to correspond with line WX. I also know that that's the corresponding side because my larger angle is on the left and my smaller angle is on the right. If you look down here, my smaller angle is on the left and my larger angle is on the right. So I know that that cannot correspond with line AB. Now let's look at line AD. So line AD corresponds with line WZ. And again, I know that these correspond because I have my greater angle on top, or my obtuse angle up top, and my acute angle down below. Okay. Let's go with blue. Line DC. DC is this one, and on this one, I know my acute angle is on the left and my obtuse angle is on the right. So then I know that this one is the one that matches it because it has the acute angle on the left and the obtuse on the right. And then last but not least is line YZ, not YZ, YX, sorry. And I know that that one matches with line CD. One, because it's my last one, but also because I have my acute angle on top and my obtuse at the bottom. And so the same thing here. So now we can answer our question. It says, which side corresponds with AB? So what side do we highlight the same color? Line, side WX. So that is the side that corresponds with side AB. So which side corresponds with AD? Well, WZ, right? So now you complete these, pause the video, complete these two, and then come back to see if you got them right. So you're going to complete which side corresponds with DC and which side corresponds with BC. So pause it for a little bit and then come back. All right, so you should be back and have completed the last two on the corresponding sides. So which side corresponds to DC? Well, if you said ZY, you are absolutely correct. Which side corresponds to BC? If you said why you got that correct. Okay, and it should have been fairly easy because they were already color coded for you, right? All right, so going on to our next slide. Finding equivalent ratios. So which of the pairs below are equivalent ratios? So how do you find equivalent ratios? Well, you can do it two ways. You can, this first ratio is already in simplest form, so you can simplify this and see if you can get it to equal this one. Or the easiest way is just to find the cross products. If they give you the same thing, then they are equivalent ratios. So here I can do 4 times 39 and 3 times 52. If when I multiply those two sets of numbers, it gives me the same answer for each, then I know it's equivalent. So let's go ahead and try that. 39 times 4. So 4 times 9, 36. Carry your 3. 4 times 3 is 12 plus 3, 15. So that gave us 156. So now let's try it with 352. With 3 times 52, not 352. So 52 times 3. 3 times 2 is 6. That's correct. And 3 times 15. Sorry, 3 times 5 is 15. I was getting ahead of myself. Sorry, guys. So 3 times 5 is 15. So that gave us 156. Did we get the same for each? Yes, so that means they are equivalent ratios. So this one checks out. So then you would check the next one. So let's check this next one. So again, we're gonna find our cross products. So we're gonna have 7 times 132 is equal to 11 times 84. All right, so let's try that. So 132 times 7. What does that give us? So 7 times 2, 14, carry your 1. 7 times 3, 21, right? Plus 1, 22. And then 7 times 1 is 7 plus 2, 9. So this gave us 924. Huh? So now you got to multiply 84 times 11. What does that give you? So 1 times 4 is 4. 1 times 8 is 8. Put your placeholder. We're done with our 1. We can cross it off. 1 times 4 is 4. 1 times 8 is 8. So 4 plus 0 is 4. 8 plus 4, 12. Carry your 1. So 1 and 9. 1 and 8 is 9. Sorry. So 924. Did it give us the same thing? Yes. So this one also checks off. All right. So I am going to, hopefully you have this part here because I am about to erase it. If you don't have it and I started to erase it, rewind a little bit and pause it so that you can finish copying it. All right, so we can try it. You're going to try this last one by yourself. Okay. And you're going to tell me, is it equivalent? So you have 12/13 is equal to 240 of 260. So you're going to find your cross products and multiply. So you're going to have 12 times 260 is equal to 13 times 240. Are those two equivalent? So you're going to multiply those two. If they each give you the same answer like these did, then yes, it is equivalent. If they don't, then it is not equivalent. Okay. So go ahead, pause your video, finish working that one out. All right, if you're coming back after having your video paused, okay, you should have got 3120 for both of these. So were they equivalent? Yes, that checks off. So it says which of the pairs below are equivalent? They are all equivalent. Okay. So sometimes you're gonna have some that are not equivalent, right? But for this one, we made sure they were all equivalent. All right, so let's go ahead and move on to our next slide. Now, it looks like everything erased except this one little pink line here. So we'll erase it. All right, so it says adjacent lengths. So in similar figures, the ratios of adjacent lengths within each figure are equivalent. Set two ratios equal to each other and find the cross products. So with similar figures, you have adjacent lengths, okay? And those are lengths that are like across from each other. Okay. So we're gonna set two ratios that are equal. So like AD and DC, those are adjacent lengths. Then WZ and ZY. So we're gonna find the cross products. Finish setting up these ratios and find the cross products. Sorry. So the measurement for line AD is right here. So that is 11. So I'm gonna plug it in here. Now we have the measurement for WZ down here, which is 16.5. And then we have the measurement down here for ZY, which is 21. So you're doing the same thing we did previously, checking if the finding the cross products. So now you're going to take these and you're going to have 11 over 14 is equal to 16.5 over 21. So you're going to find the cross products for those two. Okay. So go ahead and do those and come back and check to make sure you got them correct. So pause your video. I'll give you a little bit of time before I actually post the answer. All right, when you multiplied 11 times 21, you should have got 231. So what did you get for 14 times 16.5? Okay. Did you get 231 also? Yes, that is correct. So these are equivalent or corresponding sides. They're proportional. Okay. So that's what we mean by corresponding sides are proportional. So this side is a portion of this side. So you see it it increases by an equivalent part. So each side increases by an equivalent, an equal ratio of the previous side. So each side increases by an equal ratio of each side. All right, so moving on to our next slide, slide 12. Let me go ahead and move on down so we can see. Okay, we're almost done with our notes. All right, so it says corresponding lengths. In similar figures, the ratios of corresponding lengths between figures are also equivalent. So we're looking at lengths. Oh, that pink line keeps popping up. Oh, okay. Between figures are also equivalent. Set the two ratios equal to each other and find the cross product. So again, it's showing you the same thing again. So here we have 11 times 14. And then, oh, sorry, I did that wrong. I was supposed to erase. Okay, so AD is 11. WZ from our previous slide we know is 16.5, right? Because it had the length. And then DC is 14. So now we're going to set our ratios equivalent to each other and see if we still get a if our cross products are still equal. So you're going to multiply each of these. So 11 times 21 and 16.5 times 14. Go ahead and pause your video and work those two out and give you a little bit of time. All right, if you're coming back, so 11 times 21 gave you what? 231. That is correct. So did 16.5 times 14 also give you 220 and 31? Sorry. Yes, it should have. All right, so these are equivalent. So see how it doesn't matter if you do the two sides from um, the same shape as one ratio, or if you do corresponding sides as one ratio. So on the previous one, we had AD over DC and WZ over ZY. And on here, if you look, we have AD over WZ because those are corresponding sides. And then we have DC over ZY. So those are corresponding sides. So you can have adjacent sides, which are the sides from the same shape, or you can have corresponding sides, which are the sides of the same color. Okay? So your proportion has to match in some form. Okay? So where here it matched that it was from the small shape, and then here was the bigger shape. Here you had the blue link on top and the green one on the bottom. So you had blue on top and green at the bottom. Okay, so that's how those matched. All right. So now, what did you notice when you did the cross products for the two proportions? So what did you notice? Okay, so go ahead and answer that question. I believe you have it on your notes. If you don't, find a blank space either on the sides or at the bottom and respond to that question. All right, so pause your video so you have time to write this sentence stem and finish responding to it, and then come back for the next slide. All right, slide 14. We are almost done. We have two more before I think pair share, and then you will complete your independent practice. So this triangle ABC is similar to triangle XYZ. Which angle corresponds to angle BAC? So we're looking at angle BAC. So that means we want to know the measurement for basically A. If you look, BAC, so we want to know this angle measurement here, or which corresponds to this one. So we started at the top. So here, if you look, these shapes are facing different directions, but I'm going to start at the top, come to the middle. Wait, so it's Y, X, C is the angle that matches that. So I'm going to write it as angle YXC. Okay. So now which angle corresponds to angle CYX? So I'm going to erase the green so that we can now find our next one. So it says which angle corresponds to angle CYX. Oops, I did that wrong. Sorry. Let me erase it. I went in the wrong. I went to CX instead of CY. Sorry. So we're looking at angle CYX. So basically, we want to know which one corresponds with Y. CYX. So now I'm going to do this on the bigger one. It's going to be CBA. So that means that Y and B correspond. So we have to do it in the same order, write it in the same order we started. We went to C, then we went to B, and then we came down to A, CBA. Okay? So now it wants to ask you which side corresponds to side CY. So let's erase this red so we can find our corresponding sides. So go back to the pen. So I'm going to start with side AB. Side AB is going to correspond to which side? Well, it's going to correspond to side YX if you said that is correct. And we know that because that is our slanted side or our hypotenuse. And so that is this is our slanted side on this one. So we know that that one's gonna be the one that matches to A. So it is the one that is directly across from our right angle. That's what I mean by hypotenuse. Then we have line AC. Which line corresponds to line AC? Well, if you said line CX, sorry, you are correct, CX. And then last but not least, BC corresponds to line YC, the same thing. Okay, so which side corresponds to CY? Well, BC. And this one, they're up back to back, so that they share that part of that line. But, okay, so which side corresponds to BA? So you should know this by looking at your colors. So go ahead and fill that in. Okay, and if you said that line YX corresponds to BA, you are absolutely correct. Okay, so I'm gonna go ahead and clear that. Remember, if I ever clear it too soon, you can come back, rewind, and pause in order to be able to write that stuff down. So now this example says trapezoid QRST is similar to trapezoid WXYZ. So it says which angle corresponds to angle S? So we're looking at angle S. So which one is going to correspond to angle S? Is it X? No, it's not going to be X. Look at your shapes. Are they facing the same direction? Sorry, are they facing the same direction? No, they are not. If you look, this one has the wider side or the bigger side of the trapezoid to the left, and this one has the wider side of the trapezoid to the right. So that means that angle S is going to correspond with angle Y. So now we're going to look at angle W. So angle W is here. So which one corresponds to angle W? If you said angle Q, you are correct. I didn't put my angle sign. Sorry, guys. Fixed it. All right, so now which side corresponds to side WZ? So let's look. Side WC, which side does that correspond to? Okay. So is it the slanted side or the straight side from the trapezoid? Okay. So it is the straight side, so it's going to be the bottom, so QT. So which one corresponds to WZ? QT. And then which side corresponds to ST? So let's look at ST. ST is here. So which side is going to correspond to ST? Is it going to be YZ or XW? So look at it. Look at your trapezoid here. Is it the shorter end of the trapezoid or is it the wider side of the trapezoid or the smaller side of the trapezoid? The thinner side. Yeah, it is the thinner side, right? So ST is on the thinner side. So which is on the thinner side? Is it YZ or XW? If you said YZ, you are correct. So remember, I told you they're not always going to be facing the same direction. So like these, the previous ones were facing back to back. These are facing like you could say face to face. Okay. So it says now our next part from this one says write and solve a proportion to find the value n by comparing adjacent lengths within the similar figure. So remember, for this one, we're finding adjacent lengths. So I need to use the sides that have actual information. So I can't use ST here because it doesn't have a number on it. So I don't know that length measurement. I need to use N because it's telling me to find the value for N. But I need another measurement from that trapezoid. So I need to use RQ because that one has a measurement. So the same thing here. I'm going to use ZW because that's what corresponds with QT where my N is. But I need the corresponding side for RQ, which is XW. So now that I have this, I can set up my um, my proportion, and it says adjacent link, so that means that it's within the similar figure. So that means that I'm gonna have 6n because it's RQ over QT. So 6n is equal to, my 6 is my yellow side, so that's gonna be 12, and my n is the pink side, so that's gonna be 24. And so this would be XW over ZW. Okay, so now that I have these two, I can find my, it's like solving a proportion. You're going back to solving proportions. I want to find the value of n, so I'm going to have 6 times 24 and n times 12. So I'm going to erase this. No, I'm not going to erase it. I'm going to leave it there. So I have 6 times 24 is equal to n times 12, which is 12n. And then 6 times 24. So what is 24 times 6? That's a 6, and this is a 4. Sorry, guys. So 6 times 24 gave me 144. So 144 equals 12n. Now I have to divide by my number in front of the variable to get my answer. So let me change the color so I can write it here. So n equals 12. Okay. And I am going to have to erase this so we can do our next one. So let me rewrite this part. Try to write it a little bit smaller, see if it works. So 144 over 12. All right. So now we're going to do this next section. I'm going to write in a different color. It says write and solve the proportion to find the value of n by comparing corresponding lengths. So now instead of adjacent angles, which are within the same shape, so I had 6 over n and 12 over 24, I'm going to compare corresponding sides. So I am going to have 6, which is my yellow. Well, let me write it in the color that corresponds with it. So 6, and which side corresponds with 6? 12. So 6 over 12 is equal to, go to repeat, n over 24. And so even though like I'm comparing sides here, if you look, my proportion still matches on top. Here, my ratio is corresponding sides, one on top of the other. And then here, across on my proportion, I have the same shape. So it's the 6 from the smaller one and the n from the smaller trapezoid, and then 12 and 24, which are from the larger trapezoid. So they match going up and down and across as well. Okay, so now you're actually going to solve this on your own. So the way I solved this top one, you're going to solve it. And does it give you the same answer for n? Okay. All right. If I erased that too soon, you can go back, rewind and pause to go to and copy what I have and finish solving it. So remember, you're going to find the cross products and divide to find if you get the same thing for n again. So you're seeing pair share. Why do the cross products of the two proportions come out to be equivalent? So why do they come out to be equivalent? So the cross products of the two proportions come out to be equivalent because, okay, so finish that question out. Okay. All right, and if you say they come out to be equivalent because they are proportional, you are correct. So they come out to be equivalent because the ratios are proportional. Let me write that. And go back there. Let me do it because the ratios are proportional. Okay, and remember you have to write the whole sentence stem and then finish it off. All right. So now we're going to our independent practice. You should have your independent practice also. It is only about 4 problems. Yes, it is only 4 questions, right? You should be able to solve them. All right. And then your exit ticket. How do we determine if 2 ratios are equivalent? So how do we determine if 2 ratios are equivalent? Okay. Answer that on your notes. And then if you finish early, you can get a piece of notebook paper and try to figure these little cute puzzles out. Okay. So, all right. Make sure you complete your notes and your independent practice and get it turned in to your teacher. Have a good day, guys.